metal casting. We have been learning in the previous episodes that metal casting was the primary manufacturing process. This manufacturing process was in practice even thousands of years before Christ. The people who lived during Stone Age, they used this process to make arrowheads and other weapons. People who lived during ancient Mesopotamia, they used this process for their art items, for making art items and jewelry items. This manufacturing process was used. Today, the metal casting has emerged as the technology. Several components are manufactured by metal casting. Spacecraft components, automotive components, engine heads, and many domestic and industrial components are manufactured by metal casting. The principle is as follows. We have already learnt. Whenever we want to create a component, a similar cavity we create in a sand medium or some other moulding medium. The shape of the cavity will be similar to the shape of the component which we require. We melt the metal and the molten metal is poured into the cavity. The molten metal solidifies in the cavity, and after some time we break the moulding medium, then we take the casting outside. And we have seen that to create that hollow cavity, we have to use a model which we call it as pattern. This pattern is made up of wood in most of the cases, it is made up of metal, it is made up of plastic, it is made up of plaster, it is made up of wax. And we have seen the pattern allowances in the earlier episodes. And we have also learnt about the moulding medium. In most of the cases, the moulding medium is the green sand. And in the earlier episodes, we have seen the ingredients of the moulding sand. We have also seen the different properties of the moulding sand. And we have classified the casting process. So, this is the major classification of the casting process. They are mainly divided into 4 types: conventional moulding process, second one is the chemical moulding process, third one permanent mould process, and fourth one special casting process. And among the conventional moulding process, green sand moulding is widely used. In fact, our ancestors have been using this green sand moulding, and the moulding medium is not costly, and any big component can be manufactured. This is the advantage of the green sand moulding, but it has got certain drawbacks. The green sand contains moisture. If this moisture is not controlled properly, it leads to defects. And it contains clay. If this clay is not controlled properly, it leads to defects. That is why we have developed dry sand moulding, in which before pouring of the molten metal, we dry the mould. Again, there are 2 types of dry sand moulding, in which we just dry the surface of the cavity using gas torches or infrared rays. In the other case, we completely dry the mould by placing the mould in ovens for few hours. And in the flaskless moulding, we do not use any moulding flasks. And we have seen the chemical moulding process, and in the shell moulding, we use a resin, that is the phenol formaldehyde and fine silica sand. we use the mixture of these two and we use a metallic pattern, and the metallic pattern is heated up and this mixture of the resin and the fine silica sand is placed over the hard pattern. A thin layer of this mixture melts and it forms a shell. That is how we make two shells and we clamp them, and a hollow cavity is created. Then we pour the molten metal. This process offers us good surface finish and good dimensional tolerance, but this process is limited only for small castings. Of course, it has got certain advantage that the shells can be stored for prolonged time. If we are going to get an order after 6 months, a big order, now itself we can prepare the shells and keep them ready, so that when the order comes to us, immediately we can clamp the shells and we can pour the molten metal and we can get the castings. But only small castings can be made, and this resin is costly. And the another process among the chemical sand moulding process is the sodium silicate moulding. What is this sodium silicate moulding process? Let us learn in detail about this. And what is the need of the sodium silicate moulding? In the conventional sand moulding process, we face the problem, especially when we make the core. We use the core whenever we want to make a casting with some hole or with some cavity. We make the core and we suspend the core, and if the core is made up of the green sand, the core may break. So, this is one of the drawback of the green sand mould. And another drawback of the green sand mould is its poor surface finish. Green sand mould suffers from poor surface finish. And there is another important drawback of the green sand moulding. If we want to cast a component with small fins or with small details, the pattern also will be having small details, small fins, and we mould the pattern in the moulding box. When we withdraw the pattern, the cavity where these small fins are located, that cavity will be damaged. We cannot cast these small fins successfully by using green sand moulding. So, these are the important drawbacks of the green sand moulding. It is that time we have to go for other alternative process, that is the sodium silicate moulding. And in this sodium silicate moulding, we can overcome the major drawbacks which we will be facing in the conventional green sand moulding. And what are the moulding materials of the sodium silicate process? One is fresh silica sand, another one is sodium silicate, that is the binder, another one is the hardener. It may be carbon dioxide gas or Portland cement or blast furnace slag, etc. And let us see the types of sodium silicate moulding process. There are two classifications. One is self hardened sodium silicate moulding process, in which the moulding sand is hardened by mixing up of Portland cement or blast furnace slag or the ferrosilicon, etc. And the setting time will be from 2 hours, it takes even 24 hours, sometimes even more. This was developed long back, but later another process was developed, that is the carbon dioxide hardened sodium silicate moulding process, in which we mix the binder and for the hardening purpose we pass the carbon dioxide gas. This carbon dioxide gas reacts with this sodium silicate and forms a strong gel, and this gel gives strength to the mould, and the setting time is only few minutes. We have to pass the gas, carbon dioxide gas, through the sand only for few seconds, immediately it will be hardened. So, these are the two classifications of the sodium silicate moulding process. Next, let us see this carbon dioxide hardened sodium silicate moulding process, in which we add 5% of the sodium silicate binder with the fresh silica sand, and this mixture of the fresh silica sand and sodium silicate binder will be placed over the pattern inside the moulding box. After compacting the sand, not tightly, not very tightly, we compact the sand, then we pass the carbon dioxide gas through the sand all over the surface. Then this sand will be hardened. Then we have to withdraw the pattern. So, these are the cores made by sodium silicate process. So, we can see these are the cores, and these cores have got good surface finish. Not only that, their strength is good, and the other process is the self hardened sodium silicate moulding process. So, in the self hardened sodium silicate moulding process, we add Portland cement or blast furnace slag to harden the sand. We also use ferrosilicon. So, we place this mixture over the pattern inside the moulding box, and we have to leave it minimum for 2 hours. If we want additional strength, we have to leave it that like the system for more than 24 hours, then the sand will be hardened. So, that is the self hardened sodium silicate moulding process. Now, after we withdraw the pattern, the mould is ready for pouring. Most of the times, using sodium silicate moulding process, we make the cores. What are the advantages of sodium silicate process? It provides good dimensional tolerances. One of the drawbacks of the conventional sand moulding process is we do not get dimensional tolerance. If we want a component of a particular size, we take a pattern little bigger than that, taking certain allowances, and after we get the casting, the size of the casting will be bigger than the size which is required. Then we have to machine it. We do not get good dimensional tolerance in the case of the green sand moulding, whereas in the case of the sodium silicate moulding, we get good dimensional tolerance. And another advantage of the sodium silicate moulding process is it provides better surface finish to the casting. Again, this is a good benefit in this process. In the conventional green sand moulding process, the surface finish is not good. Because the surface finish is not good, we have to machine it, we have to put more efforts, we have to use more labor, but if we make the mould using sodium silicate moulding process, we get a better surface finish. This is another advantage, and it accommodates a wide range of core and mould sizes. Different sizes of cores and molds can be made. And another advantage of this sodium silicate process is the cores can be made well in advance. If we make the cores by green sand, within few hours we have to use them, otherwise the moisture will be dried out and the core may be losing its strength and it will be breaking when we pour the molten metal. Whereas a core which is made by sodium silicate moulding process, it can be stored for several hours, even several days. So, if we are going to make so many castings after 2 or 3 days, now itself we can make the cores, and they can be automated. If the foundry, if the industry is having automated system, the cores can be handled in an automated system. They can be stored well in advance and the production will be fast. We can use this for speedy productions, and though it has got certain advantages, this process has also got certain disadvantages. One is, it is expensive. The sodium silicate, that is expensive, and the sand, every time we have to use fresh silica sand. In the case of the green sand moulding, after pouring the molten metal, after the molten metal is solidified, we break the sand and we take the casting outside. That sand again we can use to make another mold by adding moisture and by adding clay. That green sand can be used again and again, that can be recycled. But in the case of the sodium silicate moulding process, it is difficult to use it again and again unless we use certain methods which are very costly. That is what I am telling, it has got poor sand recovery. In the case of the green sand moulding, it has got good sand recovery. Again we can recover the sand and we can make another mold. But in the case of the sodium silicate moulding process, the sand recovery is poor. Another disadvantages of the sodium silicate process is poor collapsibility. The advantage is it has got good hardness, that is also a problem. After the molten metal is solidified, after the casting is ready, we will be breaking the mold. It is that time the mold should be in a position to be broken up easily, but when if we make a mold with sodium silicate moulding, sometimes it becomes hard. If we pass the carbon dioxide for prolonged time, it becomes too hard and it becomes too difficult to break it. For that we have to put additional efforts which increases the cost of the production. So, this is the poor collapsibility of the sodium silicate process. Next process is the no bake moulding. So, to overcome the problems of the green sand moulding, people have developed the sodium silicate moulding process, that is the self hardened and the carbon dioxide hardened. In the beginning, they have developed self hardened sodium silicate moulding process, in which after preparing the moulding sand, after preparing the sand which is mixed with sodium silicate, they used to store the sand in the moulding box for several hours. To get additional strength, they used to bake it, means they used to place the moulding box in an oven for some time. Baking means we will put it in an oven. So, people were calling it as the baking moulding system, but that was causing some problems, that was taking lot of time. Later people developed carbon dioxide hardened sodium silicate moulding process, but that was expensive. Later people developed this no bake moulding, in which we are not going to bake the mold, we are not going to place the mold in any oven. The pattern used is wood or metal or plastic. What is the moulding material? Fine silica sand plus urethane binder. When we mix urethane binder with fine silica sand, it will be hardened within few minutes. So, we mix the urethane binder with fine silica sand, we place the pattern inside the moulding box and we place this silica sand and urethane binder mixture over the pattern. Within few minutes it will be hardened at room temperature. We do not have to pass carbon dioxide, we do not have to bake it, within few minutes it will be hardened. So, this is the advantage and the special feature of the no-bake moulding system, and it offers excellent dimensional tolerance. Unlike green sand moulding where there is the dimensional tolerance is poor, but in this system the dimensional tolerance is very good and the surface finish is good, but the only limitation is this binder, this urethane is very expensive. And we can see here this no bake moulding sand is prepared, and because this urethane reacts with silica sand very quickly, within few minutes it will be hardened. So, the mould should be done quickly, not that we can mix the sands for some time and we can leave it just like that for some time, because it will be hardened. So, once we prepare the sand, immediately we should prepare the mould. Here the mould is prepared, and here we can see the mould, for even from its appearance we can see it has got good surface finish and also it offers good dimensional tolerance. Next one, let us see the permanent mould process. What is the drawbacks of the sand moulding process? The major drawback of the sand moulding process is we make the sand mould with the required cavity inside. We pour the molten metal. After some time the molten metal will be solidified. After solidification is over, we break the sand and the casting is taken out. If we have to make one more casting, we have to make another mould. The previous mould which we have prepared cannot be used for making another casting. In the green sand moulding, the mould is not permanent, every time we will be breaking it. So, making the mould, that takes time, aligning the boxes, that takes time. So, we wanted to overcome this drawback, that is how this permanent mould process was developed. So, in the permanent moulding process, the moulding material is made up of a metallic alloy. So, in the permanent moulding process, a metallic mould is used in the place of the sand, and this mould will be permanent. Unlike green sand moulding, we are not going to break the mould after solidification is over. After solidification is over, we will only withdraw the casting from the mould, and the same mould, same metallic mould, we can use it for making another casting. After the another casting is over, we can use the same mould for making another casting. Thus, we can make thousands of castings using a set of moulds, metallic moulds. So, this is the special feature of the permanent moulding process, and this permanent metallic mould is known as the die. So, this permanent moulding process is also known as die casting. Permanent moulding process is also known as die casting, and the mould material is metal or alloy. There are two types of die casting process. One is gravity die casting, in which there will be a set of moulding boxes and we pour the molten metal, and the molten metal is falling into the hollow cavity inside the moulding boxes by gravity. We are not applying any external pressure. So, this is the gravity die casting, and the next type is pressure die casting, in which there will be a set of moulding boxes made up of metal or alloy, and the molten metal is injected by external pressure. So, this is the pressure die casting. Again, this pressure die casting is divided into two types. One is cold chamber pressure die casting and the other is hot chamber pressure die casting. In the cold chamber pressure die casting, the melting furnace will be away from the system. The furnace will be away From there we will be bringing the molten metal in a ladle, then we will bring the molten metal to the cold chamber die casting machine and we pour the molten metal. In the case of the hot chamber pressure die casting machine and in this system, the furnace will be the integral part of the hot chamber die casting machine. We do not have to carry the molten metal from the furnace which is far away from the die casting machine. So, this is the difference between the cold chamber die casting machine and hot chamber die casting machines. Let us see this gravity die casting. So, this is the component we want to make and these are the metallic molds. We can see two metallic molds and the shape of the component which we want is engraved in the two moulding boxes. Half of the cavity is engraved in this box and half of the cavity is engraved in this box. And there should be a provision to pour the molten metal which we call it as sprue. Sprue is the passage through which we pour the molten metal into the cavity. So, this is the sprue. Even the sprue is engraved. Half of the sprue passage is engraved in this box, in this one, and half of the sprue is engraved in this. And when we close this box, inside there is a cavity which is similar to the component which we want. Even the sprue and the pouring cup are there when we close the boxes. And we pour the molten metal through the pouring cup and the molten metal comes down and this is the gate, through the gates it will be passing into the cavity and after solidification the boxes will be removed, they will be opened and the casting will be withdrawn. Next one, among the pressure die casting machines, I have already told there are two types, one is cold chamber pressure die casting machine and the other one is hot chamber die casting machine. Let us see this cold chamber pressure die casting machine. The important feature of the cold chamber pressure die casting machine is the furnace, melting furnace will be far away from this die casting machine. So, we can see here this is the cold chamber pressure die casting machine and here we can see this black ones, these are the two dies and inside we can see the hollow cavity and the molten metal is brought from the furnace in a ladle and it is poured here. Of course, here the dies are closed, the two dies are closed. When we close the two dies, inside there will be a hollow cavity whose shape is similar to the component which we want. And after the molten metal is poured here, the molten metal is injected into the cavity and here we can see the molten metal is entering into the cavity and this takes only fraction of seconds and after the molten metal completely enters into the cavity, here we can see it slowly undergoes solidification and after solidification is over, the die is opened and the casting is removed. So, there will be some cooling system in which after the molten metal is injected into the cavity of the dies, the system will be cooled and after the solidification is over, we withdraw the casting and this cycle will be repeated. Again the dies will be opened, the dies will be closed and again we pour the molten metal and we will inject it and it will be solidified and the solidified casting will be taken out. Here let us see the hot chamber pressure die casting machine. The important feature of the hot chamber pressure die casting system is here the furnace is the integral part of the system. The furnace will not be outside the system. So, here we can see this is the system and these are the two dies and these two dies are closed inside we can see hollow cavity. This is the shape which we want, and here there will be ejector pins. When we press these ejector pins, the casting will be coming out, and here we can see two dies, one is stationary die and another one will be the movable die. And this is the fire box. Here we will be firing, and here is the burner, we will be firing, and this is the metal pot in which molten metal is prepared, the metal is melted, right, and this molten metal is prepared here in this metal pot. After molten metal is ready, we pass pressurized air through this way. Because we are passing pressurized air, the molten metal will be injected into the dies. It will go and it will be occupying the hollow cavity. After solidification is over, we separate the dies, and by using the ejector pins, the casting will be taken out. So, this is the hot chamber pressure die casting system, and here one of the drawback is we are using pressurized air. This pressurized air is pushing the hot metal, it is injecting the hot metal into the die cavity, and the molten metal is at a higher temperature. If we are making an aluminum casting, the melting point of aluminum is 660 degrees centigrade, and we melt the aluminum about 750 degrees centigrade, that is the pouring temperature. At that time, when we are passing the air, and there is every chance that the oxygen in the air reacts with the aluminum and it forms oxides. So, this is one of the drawbacks of this system, where air is used to inject the molten metal into the cavity. To overcome this drawback, another system has been developed, that is the another system in which we do not use the pressurized air. So, this system is similar to the previous system. Here we can see a burner, and here is the heating chamber is there, and this is the metal container, and here we are preparing the molten metal, and these are the dies. Two dies are there, one is movable die, another one is the stationary die, and these are the ejector pins. And here we are using a plunger. When this molten metal is ready, the molten metal will be going inside through this port. Then we press the plunger, the molten metal will be injected. After the molten metal occupies the cavity, after some time it will be solidified. There will be cooling system. Because of the cooling system, the casting will be solidified at a faster rate. After solidification is over, the dies will be separated, and using the ejector pins, the casting will be withdrawn. And here the previous problem is not encountering. In the previous case, the pressurized air is used, and because the pressurized air is going inside the molten metal, it will be reacting with the molten metal. Here that problem is not arising. However, here we may face another problem. The plunger may be made up of different material, and the metal may be of different material. When the plunger comes in contact with this molten metal, the material of the plunger, small traces of the plunger will be diffusing along with the molten metal. Sometimes the plunger is made up of hard materials like tungsten or molybdenum. Small traces of tungsten and molybdenum, they are diffusing into the cavity. These small traces of tungsten and molybdenum, they make the casting very hard. It is difficult to machine the casting if the casting surface contains small traces of tungsten. So, this is another drawback, important drawback of this system. Here we can see 8-ton capacity hot chamber die casting machine, and here we can see the dies, one die here, another die here, and here we can see the oven in which molten metal is prepared. So, its capacity is 800 tons. So, this machine has got automated controls. So, here we can see one operator is standing and he is controlling the different operations of this die casting machine. So, in this die casting machine we have seen the classification. The first classification is the gravity die casting system, in which the molten metal flows into the cavity because of the gravity. So, if the casting contains thin fins, molten metal may not flow into the thin fin cavities, because the molten metal is flowing by virtue of gravity. So, we are using pressure die casting machines. We use cold chamber die casting machine and we use hot chamber die casting machine. In cold chamber die casting machine, the furnace is not integral part of the die casting machine, it will be outside. So, one worker has to carry the molten metal from the furnace in a ladle and he has to pour it in the cold chamber die casting machine. By the time he carries the molten metal from the furnace to the machine, there will be a temperature drop, and the same problem may arise which is arising in the case of the gravity die casting system. And if the casting contains thin fins, because there is a temperature drop, the molten metal may not occupy the thin fins, the thin cavities. That is why we have to go for hot chamber die casting system, in which the furnace is integral part of the machine. Here itself we can see the machine furnace. The molten metal is heated up to the required temperature. When it is heated up to the required temperature, it will be injected into the dies. There is no temperature drop. So, if the casting contains thin fins, it can be successfully cast using hot chamber die casting machine. And what are the advantages of these die casting systems? One is closer dimensional accuracy. Unlike the castings obtained in the green sand moulding, here the castings have got closer dimensional accuracy. Another one is we get good surface finish on the castings. This is another advantage over the conventional sand castings. In the conventional sand castings, we get poor surface finish, but here we are getting good surface finish. And another advantage is we can use these machines for mass production. If we make one set of dies, about 10,000 castings can be made. If we have to make 10,000 of castings by conventional sand moulding, 10,000 moulds we have to make. That moulding time will be much more, but here there is no moulding time. Only one set of moulding boxes we are using for hundreds and thousands of castings. So, the production time will be very fast, the production will be very fast. Another advantage, less floor area is required. In the case of the conventional sand casting, the floor area required will be more. There will be a shop for pattern making, there will be a shop for sand testing, there will be a shop for sand preparation, there will be a shop for moulding, there will be a shop for melting, there will be a shop for pouring, there will be a shop for fettling. fettling means the molten metal will be solidified in the sprue passage and in the riser and in the gating system. These are the extra projections, these have to be cut out. So, in the fettling shop we cut out the extra portions, extra projections. So, for fettling there will be one more shop, for cleaning there will be one more shop, for inspection there will be one more shop. So, the total floor area required in the case of the conventional sand casting system is very large. But here in the case of the die casting, what is the floor area required? There is no moulding shop. Because we are not making mould every time, we are using a permanent mould. Unless we use cold chamber die casting machine and gravity die casting, there is no need for melting shop. Melting is done within the machine, and that is how the floor area required is very less. Another advantage is cycle of operation requires less time. This is another advantage over the conventional sand casting process. In the conventional sand casting process, what is the cycle required? We prepare the sand and we prepare the mould, we melt the metal, we pour the molten metal, then we break the mould, we take the casting outside, then we carry out fettling, then we clean the casting. So, these are all the operations involved in the cycle of the green sand moulding, and the time required for this cycle is very high. But here in the case of the die casting, the cycle of operation requires less time. So, this is the another advantage. Because of this, the rate of production will be very high, and in the case of the green sand moulding, the green sand means the presence of the moisture. Because of the presence of the moisture, there will be some defects. When we pour the molten metal, when the moisture in the moulding sand comes in contact with the molten metal, it turns into vapor, and this vapor has to escape out of the mould. If it does not escape, if it stays inside the mould cavity, it leads to defects like blowholes and pin porosity. So, in the case of the die casting, there is no question of moisture in the mould. We are using metallic molds. So, the question of porosity or blowholes does not arise, and the rate of production is very high. And another advantage is even semi skilled workers can do the job. In the case of the sand moulding, especially for making the mould and for preparing the green sand, it requires high skill. If the moisture is more, that results in problem. If the clay is not controlled properly, that creates problem. The pattern after moulding, it should be withdrawn carefully, otherwise the mould cavity will be damaged. So, at every stage skilled workers are required, but here that much skilled workers are not required to operate this machine. And in overall, less defects will be encountered in the die casting compared to conventional sand casting. And another drawback of the green sand castings is, after solidification is over, the sand casting surface will be having sand adhered to it, because we have cast it inside a sand mould. For that we have to clean it. But in the case of the die casting, the question of sand sticking to the casting does not arise. There is no sand mould, we are using a metallic mould. This is another advantage. So, it has got several advantages over the conventional sand casting process, yet it has got some limitations. Let us see the limitations. The cost of the die is very high, because the die material will be some special alloy we will be seeing the material of the die. So, the die material is very costly. In the case of the conventional sand casting process, the moulding material is not costly. We are using silica sand, clay and moisture. These are not costly, but here we are using some special steels which are very costly, and even to make this die we have to put lot of efforts. To machine the die, it is very difficult. To make the die, it is very difficult. We have to put lots and lots of efforts, and it is not suitable for heavy castings. Big castings cannot be made by this die casting. In the case of the conventional sand castings, size is the flexibility. We can make small castings, we can make medium size castings, we can make very big castings. That is the big advantage of the conventional sand casting process. But here we can make only small castings and medium size castings. And this process is suitable only for non-ferrous castings, like making aluminum castings. We can use this process, and this is not suitable for small scale production. If we have to make a casting, say the number of pieces required are some 10 or 20, this process cannot be used, because first we have to make the metallic mould. This metallic mould is made up of a special steel, and we have to engrave the required cavity in the metallic mould. With much efforts, much difficulty, we have to create the cavity. After that, if it has to be used only for 10 castings or 20 castings, it is not economical. This can be used only for large scale production, not for small scale production. And what are the applications of the die casting? Carburetor bodies of the automobiles, they are made up of die casting. Hydraulic brake cylinders of the automotives are manufactured by die casting. Connecting rods and automotive pistons, they are manufactured by die casting. Oil pump bodies, they are manufactured by die casting. Aircraft components are manufactured by die casting. These are only few cases I have explained. In fact, there are many more applications of the die casting. There are many more domestic and industrial applications of die casting. Now let us see the die materials. What is this die made up of? What is the material of the die used in the die casting? There are totally 6 types of materials are used. They are known as H11 steel, H12 steel, H13 steel, H19 steel, H20 steel, H21 steel. And the composition of the H11 steel is carbon 0.35%, chromium 5%, molybdenum 1.5%, vanadium 0.5%. This die material used to make zinc castings. For making zinc castings, we use this die material. And there is another steel. Of course, the balance material will be iron here. H12 steel, and the carbon is 0.35, chromium 0.5, molybdenum 1.5, tungsten 1.5, vanadium 0.4, and the rest is iron. This H12 material is used for making the dies for aluminum castings. There is another steel known as H13 steel, and its composition is carbon 0.35, chromium 5%, molybdenum 1.5%, vanadium 1%, and the rest is iron. This die material is used when we have to make aluminum castings. There is another steel called H19 steel, and its composition is carbon 0.4%, chromium 4.25%, tungsten 4.25%, vanadium 2% and cobalt 4.25%. This dye material is used for brass and bronze castings. Another one, H20 steel, the carbon percent is 0.35%, chromium 2%, tungsten 9% and the rest is iron. This dye material is used for making brass and bronze castings. And there is another dye material known as H21 steel, and the composition is carbon 0.35%, chromium 3.5%, tungsten 9%. This dye material is used to make brass and bronze castings. So, these are the important dye materials, and these dye materials are very costly. So, in this lecture we have learnt about the sodium silicate moulding process, and it is mainly classified into self hardened and sodium hardened. In the self hardened, we use Portland cement or blast furnace slags to harden the sand, whereas in the case of the CO2 hardened process, we pass the carbon dioxide gas through the sand which contains sodium silicate. We have also seen no bake moulding, in which we mix urethane binder with the fine silica sand, and the sand sets in a very short time, within few minutes. That is the advantage. And we have learnt about the permanent moulding, which is also known as die casting. This die casting is broadly divided into gravity die casting and pressure die casting. Again, we have seen this pressure die casting is classified as cold chamber pressure die casting and hot chamber pressure die casting, and we have seen the advantages and limitations and applications of this process. And in the next episode, we will be learning about the centrifugal casting. Thank you.